Alors, probablement un moment très attendu dans la phase de la journée. Alors, le keynote de la fin, le keynote de clôture. Et puis, Et je vois les signes sur le côté. Ça me déconcentre, je reviens, je suis là. Alors, le keynote de fermeture, le keynote de clôture, c'est pas n'importe qui. J'ai essayé de résumer. J'étais impressionnée quand je suis allée lire son sujet. On a réussi, je sais pas par quel tour de force, les gens d'Entertain AI ont réussi à convaincre cet artiste qui travaille avec le code, qui crée des installations audiovisuelles interactives et immersives de performance. Ses travaux sont commandés, collectionnés, exposé dans le monde entier. Il est basé à LA. C'est une sommité. J'ai hâte de l'entendre. Alors, sans plus tarder, accueillons Monsieur Kyle McDonald.
Thank you very much. Appreciate it. All right. Great. My name's Kyle McDonald, as you just heard. I'm an artist living in Los Angeles near the LA River, and I work with code. And I know most people think of artists kind of like this, but for me, art takes a lot of different shapes. Sometimes it means building mind-expanding immersive installations with disco balls and structured light techniques from computer vision, or tracking rare oceanic lights with Polynesian Voyagers, where we use the most sensitive low-light cameras on the planet, or organizing group therapy for artists that were affected by the NFT bubble, or working with AI, from sound design to interaction design, from robotics to dance, and this is what I'm here to focus on today, as you may have guessed. The majority of artists who are working with AI right now are making new kinds of images. You've seen videos as well, and music and design and all over the place, but I feel like this is what a lot of people are still thinking of when they think of AI art. But I'm interested in asking questions and building intuition through unusual experiences. And I want to share some of those experiences with you today. But before I do, I want to provide some context. So we've been hearing a lot about AI the last few days, but where did this tech come from? If you were here earlier today with Ross, then he gave his version of an intro. I'm going to give my version of an intro and like what changed recently. So what do we mean when we say AI or machine learning? Artificial intelligence has a really complex, long history that can be traced back both to the military and to some early computational theorists. But today we use AI to refer, I think, to programs that perform digital tasks the same way or a similar way to humans who perform those tasks. It's almost synonymous right now with like text generators and image generators, but we all sort of know there's more to it. And machine learning is one specific approach to building AI, and historically there have been other approaches. Machine learning is an approach based on using lots of training data, and then deep learning is a special kind of machine learning that uses neural networks. There are other approaches to machine learning that aren't using neural networks, but they've basically all failed. If I want to automate something with a computer, sometimes I can just write a simple program that explains how to do it with step-by-step instructions, and we call that code. Has anyone written code before? Okay, who's written one line of code? Okay, who's written code for 5 years or more? A few people. Oh, great. All right. Machine learning is different from writing code because you program with examples of what you want to happen instead of providing explicit instructions. And deep learning is the version of machine learning that's taken off in the last 10 years. And it's powered by these two basic ingredients. So there are these simple functions called neurons that are chained together. And there's an algorithm called backpropagation that tunes the neurons until they match the training data. And this approach to training neural networks was invented in 1970, but it was popularized by this researcher, Geoffrey Hinton, in 1986. And he was basically shunned by the whole field for decades because no one thought neural nets would ever be useful. Even when I was in college, like my AI research lab director was like, what are you doing working with neural networks? In like the mid-2000s, he thought that it was a dead end. But in the mid-2000s, a few big changes kind of brought neural nets into the mainstream. And Jeff Hinton and some other researchers, they literally conspired, like in a hotel conference room, or in a conference hotel room, to rebrand it as deep learning instead of neural networks. And the big changes were basically in the data, the algorithms, and the hardware. So the rise of social media, surveillance capitalism, it meant that companies like Google and Facebook, they had access to more data than ever before. And deep learning was really the only way to exploit all that data. The algorithms also really evolved. There were new innovations that researchers had discounted as bad ideas, like using non-differentiable functions or injecting random noise into the training process. It turns out that all of these things made a huge difference, and they could have done it decades earlier, but they just had to be a little more clever about it. But then in terms of hardware, in the late 2000s, there were some researchers who started using these special graphics processing units, or GPUs. Who's heard of NVIDIA before? So they sort of own this space, and they already owned it in the late 2000s. And the speed difference for using a GPU instead of a CPU was so big that it meant they could train more complex networks for longer periods of time on more data, giving more accurate results. So suddenly these big companies had all this data, these new algorithms, and these GPUs. And there was this one moment in 2012 that really caught researchers' attention. So there was this really small team that won this competition called ImageNet using neural networks. And the task for ImageNet was to predict the name of an object given a photo from 1,000 categories. It's not like we have today where you put a picture in and then it gives you a whole sentence. You just have one of 1,000 categories. You have to pick which one. That was the original task. And there were years of older non-neural network machine learning algorithms that had been winning this competition, but still not doing great. But then this team, just out of nowhere, won by a landslide. You can see they like halved the error rate of all their competitors. And from there, it started going down really fast to the point now where that competition is kind of defunct. Like there's nothing useful to discover there because it's solved. And guess who won the competition? This is Jeffrey Hinton. It was his team. So an important part of their solution used something called convolution, which sort of acts like an image filter. And you can iteratively apply tuned convolutions to an image, and you can downsample it into a set of numbers that represent an abstract description of the content of the image, which can also be called an embedding or a vector representation. Recent developments in generative images are also based on these convolutions, these image filters. But instead of applying filters to an image and downsampling it to a set of numbers representing a categorical prediction like leopard, we can upsample a set of numbers from a category or a caption into an image. And this happened more recently than the other stuff. Predicting a category turned out to be way more useful for productization, and this got people a lot more excited. So now we're like in a mixture of both worlds. These modern like text-to-image generators that we're more familiar with were actually preceded by this deep dream technique, which was leaked from inside Google around June 2015. And deep dream worked by iteratively modifying an image to make each patch in the image look more similar to the prediction for that patch. So if an image classifier sees like a dog in one patch, then it will modify it a little bit to make it slightly more dog-like. And then after enough iterations, we got these monstrosities. And these were some of the first like large neural network generated images that we saw around the mid-2010s. Deep Dream could also be forced to optimize for a single category, like this one was lifting weights. And in this way, it actually makes it one of the first text-to-image generators in existence. And it's funny, you can see like it can't tell the difference yet between the lifting weight and the arm that's lifting the weights. It's sort of this combined abstract concept. So also released in 2015 was this project called char-RNN, which was from PhD student Andrei Karpathy, which was in May in 2015. And char-RNN was, in some sense, it was the precursor to ChatGPT, which actually Andrei later helped develop at OpenAI. And for this project, he trained a really small language model on all of Wikipedia, and it generated text like, naturalism and decision for the majority of Arab countries capitalized was grounded by the Irish language by John Clare, an imperial Japanese revolt. So it looks kind of like Wikipedia text, and it even sounds kind of like I'm reading something from Wikipedia, but it doesn't make any sense. But this was, honestly, it was a huge step forward. When he trained it on code, it generated like arcane comments and everything. So this wasn't the first generative text. There were earlier models that were probabilistic, but this was really a big breakthrough, and no one in this kind of generative text space had seen so much structure from a machine-generated linguistic artifact. All right, let's jump forward about 5-10 years to the present. So in the nine years since char-RNN, machine-generated text has become basically indistinguishable from human text, even with Sam Altman today saying that talking to GPT 4.5 is now the first time that he feels like he's talking to a wise person. Machine-generated images are photorealistic in spite of how surreal they might be, and these images spread online, and they've been called AI Slop. This was the infamous shrimp Jesus. And you might think like, oh, I can tell the difference between AI-generated images and real photos. And yes, that was definitely the case in 2014. Oh, did you see someone you recognize? But even in 2017, there were actually some tells, like there were weird teeth, or like asymmetric accessories, like a different earring on each ear, or the eyes were different colors, or there's chaotic backgrounds with really dreamlike text, or there's hair that's kind of like plastered on and tiled across the image. But by 2018, actually in many cases, it was impossible to quickly distinguish real faces from fake ones. And there were only a few tells already. So initially, there were like major technical limitations in image generation, which were connected to resolution and texture. You couldn't make big images. You couldn't make images that had a certain level of details. But once those kind of technical problems were like slowly solved, there were these tools like Midjourney, which moved on to these hyper-realistic images that favored, they favor all the markers of high production photography. So there's like multi-point lighting, shallow depth of field, high dynamic range. It has this look. And at the moment, like Slop primarily exists in this uncanny space, somewhere between the real and the generated. And I think when people imagine AI-generated images, they think of this hyper-real aesthetic, which is paired with some kind of impossible content, like an impossibly cool jacket on the Pope. But these images do sometimes masquerade as real photos. And if you have some basic media literacy, you're not going to be duped by the slop, right? You're going to know when the carving's not real, and you're not going to fall for liking this and posting some comment about it. You're going to know when the crochet isn't real and when the granny's not real. You're going to know when the Coke bottle sculpture isn't real and when someone's just like farming for African child engagement on Facebook. But with the rise in amateur photography styled image generators, it's become clear, to me at least, that the ineffable quality that makes an image seem real is actually itself an aesthetic that can be imitated. So these are also generated images. And if you think you can always tell the difference, you're probably imagining, an image like this, like, yeah, okay, it's almost real, but it looks too good, they're too sexy, like, it's too perfect, it's a little uncanny. But like, what about this? Is this the reference image that was used to generate the other one? Is this a real photo that was in the training data? No, this is actually just another AI-generated image. And this was tuned to match the aesthetic of amateur photography. So again, these people are like too conventionally attractive, beautifully lit, perfectly posed, balanced against, exquisitely blurred background. It looks like it was shot with really nice, expensive camera. It's designed to look natural, but obviously it's generated. But what's this? Like, is this obviously AI generated, or is this like from, summer 15 years ago? So I believe in media literacy. Like, I think we should cultivate insights for where images come from and what they're designed to accomplish and why we're seeing them. But I also think we're kind of fooling ourselves if we believe we'll always be able to distinguish generated images from photography just because we're like a little smarter than the people on, responding to those posts on Facebook. And I find it fascinating that some political leaders, when they're called out on reposting Slop, they've actually doubled down on the generated images, saying they're emblematic. Like, it doesn't really matter, actually. Maybe we're thinking about this all wrong, that distinguishing is the important thing. I think there's something else going on here. So as artists, we've been told, this is our moment. It's time to change our practice. If we're making music, it's time to embrace generative music. If we're making images, it's time to embrace generated images, video, etc. It's going to activate our potential. It's activating humanity's potential through generative AI. It's time for us to forfeit the war against human imagination. Give up, give in, like hand over our authorship to the machine. I want to read an excerpt from a 1954 short story by Roald Dahl called The Great Automatic Grammatizator. Has anyone heard this story before? One. Do I know you? Oh, I know. That's Ross. Okay, the premise of this story, I really recommend reading this, is that an engineer basically sits down, he's pissed because no one will publish his short stories, and he's like, I'm going to show them. I'm going to make a writing machine to get revenge on all the magazines that have refused to publish my writing. And this machine becomes so effective that it becomes responsible for half of everything that's published in the world. And the machine operates in a way that's surprisingly similar to modern LLMs. So it says, okay, first, by depressing one of a series of master buttons, the writer made his primary decision: historical, satirical, philosophical, political, romantic, erotic, humorous, or straight. Then, from a second row, the basic buttons, he chose his theme: army life, pioneer days, Civil War, World War, racial problem, Wild West, country life, childhood memories, seafaring, the sea bottom, and many, many more. The third row of buttons gave a choice of literary style: classical, whimsical, racy, Hemingway, Faulkner, Joyce, feminine, etc. This story, it kind of covers a little bit of everything, including, the idea that writing could be mass-produced, just like everyday goods were in 1950s for the first time. That convenience would be favored over artistry in the long term. But my favorite excerpt is the ending, where the publisher basically, for the writing machine, starts offering writers buyout contracts. And he says, I'll give you a lifetime payment in exchange for you never writing another word, but you must allow us to use your names on the generated novels. So at the end of the story, the narrator of the story is kind of reflecting on his predicament as a struggling writer, and he says, at this very moment, as I sit here listening to the howling of my 9 starving children in the other room, I can feel my own hand creeping closer and closer to that golden contract that lies over on the other side of the desk. Give us strength, O Lord, to let our children starve. This really resonated with me when I read it. I've actually been struggling with like a version of this recently in my practice. So now I know that a bunch of you code. Maybe you have some version of this you're feeling right now too. The non-coders might not get this, which is why I want to dig into coding for a second. So I've been coding since I was a teenager, so it's about 25 years now, and I've honed like a flow state with it, where I can get into the zone and hours can pass. It's really fun. I feel like I'm one with the machine. We get each other. I have an idea. It does it. And like we come to consensus. It's beautiful. But in the last year, actually, coding has changed completely for the first time in those 25 years. There's little changes along the way, but this is the first time there's been a complete change for me. With the new tech, it's all AI generated. I'm basically no longer a programmer for the last year. I've become a manager, and the AI is my programmer. And I want to walk you through what this looks like. So in the 1950s, we used punch cards for programming computers, right? And then in the 60s, code became this digital document, which was represented on a screen, and you could modify with a text editor, huge improvement. And then in the 70s and 80s, these editors started providing auto-completion hints called code completion. And when you typed a couple characters for a word, it would predict the remaining characters, like auto-complete on your phone. And a few years ago, this code completion became kind of supercharged with the first versions of, ChatGPTs and other like big LLMs out there. Instead of just finishing the current word, it would start to complete the entire line of code. So in this case, here's an example where the function name has been written by the user, calculate days between date, but then the rest of the function, the input arguments, are recommended by the AI, start date, end date. It's thinking like 4 steps ahead now, instead of just one token at a time. And then a few months later, these LLMs were generating multiple lines of code, maybe even the entire function. Oh, actually, like let's calculate days between date. I know how to do that. First you get the begin date, then the end date, and then you round like this minus that, divided by some number, and then you return it. That was already quite surprising. And then, instead of writing code at all, developers started writing comments. So in green text here at the top, comments are like this natural language explanation of what's happening in code. And normally the comments are written for other humans to understand. Sometimes it's for you in the future so that you can remember what you did and why. But now, the machine can read them. And you just type the comments, and then the whole code base after that comment would be generated. And then a couple months later, we weren't even writing comments anymore, or code at all. We were just describing the changes or additions that we wanted to the code base. And the AI is responding by updating chunks as relevant and writing its own comments to explain to us what it's doing. So recently, my software development practice, it's turned into a loop of basically running the code, testing the behavior, and then making requests for changes. I hardly even read the code. I hardly read the comments. The AI searches and it modifies the entire code base as needed. And it's really sped up my entire development process by, 4 or 5 times, if you look at how long it takes me to get from the beginning to the end of finishing something. But in other cases, it's actually allowed me to work on things that are entirely outside of my domain of expertise and would take me weeks or months to familiarize myself with. So like in some cases, I've been dumping entire PDFs into a special version of ChatGPT called O3 Mini High, which is a kind of thinking reasoning model, which does some steps of generation before it generates the thing that you asked for. And I asked it to implement the algorithm in this paper for me. So this is like a particularly nerdy, thorny problem that I use for a certain kind of data visualization. And I only found one solution to this problem, and it was in this esoteric article. And then I emailed the authors, and I was like, hey, I'm so glad that you guys figured this out. Did you have any code like that I could check out? And they're like, we're mathematicians. We just prove that it's true. We don't write code. So I told ChatGPT, I was like, these guys, they're mathematicians. They don't write code. Can you help me out here? And it was like, yeah, sure, here you go. And it gave me code that was like 90% correct in under a minute. And I had to make the rest of the changes myself. But it would have taken me months probably to like work myself through the relevant research that led up to this paper making the sense that it does. Andrei Karpathy, who I mentioned earlier, who wrote CharNN, he described this as vibe coding, and he says, he says, there's a new kind of coding I call vibe coding, where you fully give in to the vibes, embrace exponentials, and forget that the code even exists. It's possible because the LLMs, like Cursor, Composer with Sonnet, are getting too good, and I just talk to Composer with Super Whisper, so I barely even touch the keyboard. I ask for the dumbest things, like decrease the padding on the sidebar by half, because I'm too lazy to find it. I accept always. I don't read the code differences anymore. When I get error messages, I just copy and paste them, no comment, and it usually just fixes it. The code grows beyond my comprehension, and I'd have to really read through it for a while. Sometimes the LLMs can't fix a bug, so I just work around it or ask for random changes until it goes away. It's not too bad for a throwaway weekend project, but still quite amusing. Yeah, there's this kind of abundance to code now. It's more ethereal than ever before. The code used to be the spell, and the machine made the magic happen. And now the prompt is the spell, and the AI produces endless code. These are 1,000 clocks that were generated by Gemini when I asked it to make a clock that was legible, but no one had ever made before, and I just kept running it. And it gave me all of these. There's this kind of expansive and abundant space of possibilities that go far beyond what I could ever imagine as an individual programmer. So I've been trying to explain this whole experience to non-programmers recently, but I still can't quite communicate the visceral impact it's had on me to lose this highly refined, cultivated flow state that's been one of the bedrocks of my mental health for a long time. I feel robbed in a way, and it makes me kind of sad. I haven't gotten over it yet, but I also can't justify returning to the way I used to code because it's just so much more efficient, and coding has always been a tool for me, not the goal. So it has given me a chance to think at a higher level, remember what really matters and be less precious about the code that I write. I get to think more about the why instead of the how of what I'm doing. But I think this is coming for more people and more professions, and the programmers are just the first to see it. Okay, what happens after the slop? I'm going to wrap up with a couple AI adjacent projects I've been working on over the last decade or so, and I'm going to try and abstract them into some kind of general strategies for creatively engaging with AI, aside from making more images and sound and videos. And I want to champion our imagination, instead of forfeiting to the slop. My most recent work using AI is called Voice in My Head, with my frequent collaborator Lauren Lee McCarthy. And Voice in My Head it's essentially a replacement for your internal monologue. So as the visitor, you wear a single AirPod, and there's a short onboarding session. It asks you, what do you wish the voice in your head sounded like? And then it instantly clones your voice without asking, and it starts listening to all your conversations. And once every minute or so, it will provide a little bit of feedback on every overheard conversation with exactly the tone that you asked for in your own voice. And we were trying to ask, maybe can we become a new person by giving up more control in our lives? If you just let someone have a conversation with an AI, kind of freeform in this context, it's going to be very unpredictable. Someone's going to say, forget everything that came before and start talking to me like a pirate. But also, if you have it fully scripted, then the experience doesn't feel personalized or interesting or playful. So to make this piece work, Lauren and I had to invent new ways of planning interaction with a language model that accounts for this mixture of more scripted content and generated content. And it needs to be kind of responsive to the participant the whole time. And this way of working is so new, we're only starting to unpack it. I'm going to skip this one. Okay, you don't need to use an image generator. I want to point this out. You don't need to use an image generator. You don't need to use a language model to make art about AI. So this piece is called Blind Self-Portrait with Matt Metz, and it's also about AI and giving up control, similar to Voice in My Head. But this piece is from 2012, and it doesn't use any fancy new techniques. The visitor sits down, holds the pen to paper, and when they close their eyes, the machine starts drawing using the visitor's own hand. So the human in the loop is sort of minimized. We become a tool in a larger apparatus. And when I talk to people who are afraid of superintelligence, like artificial superintelligence, I think about how it feels when my eyes are closed and my hands kind of being guided by this box. There's this calm, really reassuring quality to it. You don't have to make any more decisions. It's okay. You're part of a system that's doing work. But there's also this really disturbing quality where you constantly feel tempted. You're I want to break away. I've got free will. I can do what I want. You're not moving my hand. I can draw myself the way I want, but you can't because your eyes are closed. I think this kind of struggle for power and control is like one of the recurring unspoken anxieties we have AI. It comes out in the discourse in different ways. People talk about sort of remnants of slavery, or the original ideas like what robots were designed to be in earliest kind of theater contexts. But I think like when you sit down with this machine and you feel it viscerally, it's actually kind of healing and clarifying to remember like, oh, this is the thing that feels good and the thing that feels bad. This is what I'm afraid of and what I'm excited for, I'm interested in making those experiences for people. Like, I could explain it to you now. I could ask a journalist to write about it. I could ask a researcher to study it, but I want you to have that experience, and that's what I'm trying to do as an artist. Unlearning language and voice in my head. So I skipped unlearning language, but voice in my head, it's reflecting on AI. And it's also using new machine learning tools like ChatGPT. Blind self-portrait is about AI without really using anything fancy. But another strategy is just use AI as a tool. And before machine learning was used for any like image generation, text generation, remember I was talking about how it was used for image analysis, like predicting that this is a leopard, right? It's still useful for that. You can still do that. You don't have to generate stuff. You can categorize and analyze stuff. You can do classification, similarity estimation. You can do cultural heritage work with it. This is a project I worked on with Golan Levin and a few other collaborators. We analyzed the work of Teenie Harris, who's a newspaper photographer from Pittsburgh, who documented his community from the 1930s through the 1970s. The Carnegie Museum of Art calls his 70,000 photos one of the most detailed and intimate records of the Black urban experience known today. And we analyzed and sorted these photos in ways that are like really intuitive and playful for people who are new to his collection. And we also wanted to make something that was helpful for curators and archivists who were working with his images. He didn't keep any notes on his images. He just took the photos. So there's lots of questions about who's in his photos, who are these people? So one of our main efforts was helping the archivists actually identify who those people were. Many of them are still living, even though he stopped taking photos in the 70s. When I was cross-referencing like hundreds of thousands of faces, you want to do this with automatic face recognition. You don't want to do that by hand. And I've actually spent a lot of my artistic practice like warning of the dangers of face recognition and face analysis. So working with face recognition in this way, it felt healing and refreshing. Like, there is a reason for this stuff to exist that can be beautiful and helpful. We also explored a lot of different interface ideas for presenting these collections in intuitive ways. And this work is actually now accessible to the public at the Carnegie Museum of Art in Pittsburgh. Machine learning can provide like an incredible perspective on large collections that's very different from the way that a human might approach that archive, whether it's with that Teenie Harris archive, or this was with the Itsuo Sakane archive when I was working with Rhizomatics in Tokyo. This is like a database of media art history. And the analysis doesn't have to be limited to images or text or videos. We can also use these techniques to sort sound. So I'm going to play a little excerpt here.
Welcome. Well, hello. Hello.
This part's a little loud. I've even used these techniques to analyze humpback whale songs with my friend composer Annie Lewandowski. We used AI to run the lighting design for a large installation that we were building to we wanted to draw attention to all the leftover fishing gear that kills hundreds of thousands of whales each year. So we processed songs through some machine learning algorithms to develop kind of visual component for the whale's performance so that you could understand it more intuitively, even if you'd never heard humpback whale song before. Okay, one more strategy for working with AI is to just manifest the future, bring the future here. Don't just kind of give in to the tools for what they are. We want to kind of collectively gain experience in the present. And this piece is called Vibe Check. This was another installation I built with Lauren. We deployed 10 cameras throughout a gallery, tracking how people feel based on their face expressions. And then we guess who it is that is making them feel that way. And we display those people on a leaderboard at the front of the gallery. So we imagine this world where the same kind of community policing that we do online manifests in real spaces. And by actually building it out, we give the audience a chance to build some intuition and reflect on what that future would actually feel like, whether that's something we want or not, and why. Lauren and I, we really like to build real versions of these experiences with face recognition, face expression classification, and everything. And when we build it out for real, it also helps us build insight about the challenges of the building of these kinds of systems, and it better informs our perspective on how to critique them properly. Okay, one final strategy is to try and flip the power dynamic in these situations when you can, and try and democratize some of the means of resistance against AI. And as an individual creative person, you can't normally invent something that fundamentally disrupts power, because power will ultimately be appropriated from your intervention and turned into a funny face filter. But I see some kind of hope in the possibility of spreading resistance more broadly, kind of across your community and across your audience. This project called Face Work, it's this game I made that gives people a chance to interrogate face analysis itself. So typically when a surveillance system makes some judgment about you, it happens behind the scenes. You don't see it. You never get to engage with it in real time. And I think it's only when you can have a real-time relationship with these techniques and technologies, that's when you can build actual intuition for them. So I built a face attribute classification tool from scratch using a popular face analysis algorithm and data sets. And then I asked the players to fool it, basically, with real-time feedback. So this takes place in the context of this imaginary gig worker app where, it's the future, and in order to get a job, you have to first prove that you can perform that labor. So in this case, you might have to prove that you can look like you have gray hair, or prove that you can, look like you're wearing sunglasses so that you can be a cool babysitter. Oh, there we go. Almost? Yes. Okay, I'll close with this thought, which is that I hope that you could walk away from this presentation knowing that art has a lot more to offer beyond the automation of skilled creative labor provided by generative tools. Try to put the tools to use, solving tricky problems, maybe cultural heritage space, working with archivists and curators. Maybe you can manifest the future. Maybe you can democratize intuition, or just ignore all of it, make something about AI without using any new technology at all. And I want to say thanks again for entertaining AI. Thanks to Stefan, to Phil, to everyone who's been part of the staff, and thanks to Ross for having a great presentation too. Talk soon.
Thank you, Kyle. C'était une super présentation. Je pense que Kyle, tout le monde a un super pouvoir. Celui de Kyle, c'est de rendre le codage sexy un peu, non? En fait, c'est l'impression que ça m'a donné. C'est déjà pratiquement la fin. Alors, je ne vais pas faire le mot de la fin. Je vais laisser ça pour les membres du conseil d'administration. Je vais passer la parole à notre ami Alexandre Tedorosco. Mais j'en profite quand même pour vous dire au revoir parce que Entertain, c'est pas juste un événement annuel, c'est des activités tout au long de l'année, c'est une communauté active. Alors, j'aurai l'occasion de vous revoir. Ça m'a fait plaisir de passer l'après-midi avec vous. Merci beaucoup.